Welcome to qnawire.
Hey guys, how you doing? This is actually my second recording because in the first I actually forgot to open my mic. So let's get started. So the equation that I've been given is y equals to fourth root of x minus x, and I have to find the equation of a tangent line to this graph. Tangent, let me write that down, at the point 1 0. Okay, so the first thing that you notice about this graph is that this is the graph of something that you have no idea about, because we are never taught, generally we are never taught about something of the fourth root or the fifth root or the sixth root of something, and the graph of that is an absolutely rare exception. So the first thing that you have to know is that the rate of change of this graph is not constant, because this is not a straight line, and the constant rate is only of the graph of a straight line, and the straight line is of the form of mx plus c, where you cannot see mx anywhere here, and the power is not 1. If the graph is linear, then the power is 1. When the power of the x is 1, then the graph has a constant rate, but the graph does not here in any shape have a constant rate. So we have to use calculus here. In calculus, generally I mean differentiation. Use differentiation to get the first derivative of this equation. The first derivative is actually the gradient function of this equation. A gradient function is a function which gives the gradient of this actual equation at any point x. So we first differentiate this and we get dy by dx. Oh, first I forgot a thing. It is actually going to be a little difficult to differentiate this equation without rewriting it first. So first of all, rewrite this equation, and I mean this fourth root. You have to rewrite it so that you can differentiate it easily. We know that there is a property, a power property of indices, which is eighth root of x is equal to x1 raised to the power 1 over a, and we are going to use this. So y equals to x raised to the power 1 over 4, because it is the fourth root of x, and we leave the other x like that. Then we perform the differentiation here, dy by dx, and now notice that you are going to have to use the power rule. The power rule of differentiation states that if x has a power n, then its derivative would be n would become the multiple of x, and x in the new power would be n minus 1. The new power would be 1 less than the previous power. So we do that here as well. 1 by 4 becomes the multiple, and the new power is 1 by 4 minus 1. And similarly, we do that same to the other x minus. It has the power of 1. 1 becomes multiple. X 1 minus 1 is the new power, and we simplify this to get 1 over 4. X 1 by 4 minus 1 results to minus 3 over 4, and 1 minus 1 results to 0, and x 0 is equal to 1 using the rules of indices, and we get minus 1 into 1. Okay, so we get dy by dx is equal to 1 by 4 x minus 3 by 4 minus 1. So now you have to recall something. You have to recall that the first derivative is the gradient function, which it means that it gives the gradient m of the straight line, m of the tangent line to the graph at point x. So you can use the variable m in place of dy by dx here. Okay, now we have to find the gradient at the point 1 0. Notice that there's x only here, to substitute x equals to 1. 1 by 4, substitute 1 instead of x, 1 minus 3 by 4, and minus 1. Notice that any power of 1 is actually 1. So 1 by 4, 1 raised to power any power is 1. So this is 1 minus 1. 1 by 4 minus 1 results to minus 3 by 4. Let me clear some space here. This is a very painful process, but I'll have to go through it. Just a minute. We'll continue this after I clear some space here. A little more. Remember that the gradient is minus 3 by 4. You are going to use that and the point that we are given 1 0 to find the equation of tangent using a special equation of a straight line. Let me tell you about that. A little more, just a little. Nah, this is good. Okay, so there is something known as point slope form. It's actually like this: y minus y1 is equal to mx minus x1, where x1 and y1 are a point that you have to substitute, and notice that that's 1 and 1 0 that we have, and m is minus 3 by 4 that we have. So just substitute that. Y minus y1 is 0, as you see here. Y minus 0 is equal to m is minus 3 by 4, as you see here, minus 3 by 4, and x1 is actually 1, so you substitute 1 here, and y is equal to minus 3 by 4x plus minus and minus becomes plus 3 by 4. 3 by 4 times 1 is 3 by 4. So you get the equation of the tangent line at point 1 0 to the graph of this equation is y equals to minus 3 by 4x plus 3 by 4. And that's it. Let's recall all that we've done. First, let me just clear a little space. Yeah, this is right here. Okay, so first we found the first derivative using differentiation, then we substituted x, and then we got the gradient m. Then we substituted gradient m and the point that we were given 1 0 into the point slope form, and we got the equation of the tangent line. So this was an easy question. I hope this helped you a lot.